welcome to the first talk today in this room. Alper Basaran will give an introduction to exploit development for newbies.
Okay, thank you. Welcome. How many of you were at my presentation yesterday? Wow. Okay. So I just would like to go over the highlights for, I think there are one or two people that were not there, just to go over the thing. Well, the main idea was that I'm Turkish and these are Turkish delights. So again, if you could just pass them around. That was the important part, yes. Thank you. Well, today we are going to talk about exploit development for noobs, but as I always say, I'm not a hacker, I'm a penetration tester. So I had to learn these things and it took me some time, so I'm just going to explain it the way I learned it. So it might be boring for some of us, interesting from others. Sorry anyway. So I arrived in Serbia 2 days ago, and this was the first thing I saw at the airport. And this was the question I'm always asking: how come we still cannot write a decent piece of software, software that doesn't fail? Why, it's 2015 already, and we still write software with bugs and errors, and that is still hackable? I mean, is it just our company that cannot do that? I just compiled some examples. Here, Mars Climate Orbiter was launched in December '98. It was supposed to reach Mars and turn around or orbit Mars for some time in order to gather information on the climate. What happened is that it entered the orbit lower than it was planned and it crashed. So this was like a $300 million piece of software that crashed because the coder who was writing the code, during this trajectory calculation, he just took two different units of measure and he multiplied them. So the result was something very strange, and it crashed. Again, Mariner was planned to go to Venus for to look around. I think they have things that look like seas, and we wanted to know if there were fish in it, maybe. And the guy who wrote the code thought that this line, in fact, which I don't even know what it is. Someone told me once it was Fortran, but I don't know. So this line, he thought it was a line between two words in the upper line. So instead of a mathematical formula like this, and this also satellite had to be destroyed because it deviated from the trajectory, and instead of going to space, it was going on a city, and they had to blow it up. Knight was a company that bought and sold stock in the United States, and they had some servers that did this automatically. So if they found a stock that was lower than it should be, it bought it, and when the price went up, it sold it. It did this automatically for as long as it could. And they decided to update this software, and without testing it, they deployed the update. And what happened is that in around 30 minutes, they lost over $400 million because the software was buying high and selling when the prices dropped. So again, mistake. And more mistakes that we are familiar with. Well, Heartbleed, Ghost, these are the two ones that have their own logos, which is interesting for a bug, and Adobe Flash Player. So what happens? What makes us not able to write code that doesn't have flaws? There are three main reasons. One, the softwares are complicated, really. It becomes more and more complicated. If you were going to write a software for a fridge, for example, right? Software for a fridge, you would think temperature and maybe the gas in it. But today, the fridge, we know that they can send emails or, check your schedule. So this is not something you would think of when writing a software for a fridge. And they are very easily expandable. By expandable, I don't mean that it can be integrated with other solutions. It's just it grows so fast and so much that you don't even notice it while you are writing the code. And the last point is that, yes, we are trying to connect everything to the internet, so it becomes dangerous. Complicated, yes, we spoke about satellites just a few minutes ago. So Curiosity has around 5 million lines of code. And Windows 3.1, if we decided to write a Windows 3.1, we'd have to write over 2 million lines of code. Today, the Office 2013 has over 40 million lines of code, and Facebook is at 61 million lines of code and growing. So why would these lines of code be interesting? Because statistics shows that on any piece of software that was sold or distributed professionally, that is, there are around 15 and 50, between 15 and 50 errors for every 1,000 lines of codes. So that's why the line of codes is an important parameter for us. The clean room technique, this is how NASA and the other big guys, they are developing their software. Even them, they are not at 0 errors. So we make errors while we are writing the codes. And what does it mean for us in security? It means that on any client in our network, we have around 150,000 errors that can be potentially exploited. We said that expansion was very easy, that we didn't even notice it sometimes. Just to give you an idea about this. If I was going to use Python and print a number, I want a number on that screen. The thing I could do would be this, right? But if I decided I wanted a random number, what I could do was import a function called random, and then just print it from using that function. Let's say I want a number between 1 and 10. This is, the way I could do it. So just 2 lines of code, and it allows me to print random numbers on the screen. This is what we have just seen. But when I said import random, I just included this into my 2 lines of code. So all this, which I didn't write, which I didn't audit, which I have no idea about what it's doing, except that it tries to provide me with a random number, I included 692 lines of code in my 2 lines. So in fact, my 2 lines here, there are 694 lines of code. So that's why it's getting out of hand really easily or really quickly. And of course, we are trying to connect everything to the internet. This is, a good thing for some, not so good thing for others. The idea of connecting everything to the internet was a good idea, in fact, but we decided to do it probably in the most stupid way we could, because someone came up with the idea of browsers. We said that we are going to use browsers. In my talk yesterday, I said that, okay, this is our security posture. We are trying to protect ourselves from whatever is coming from the internet using this layered approach. So we have the firewall, the IPS. I said it was like in the Middle Ages when you were trying to protect your castle. And the attackers today, instead of going, security measure from security measure, they just popped in the middle of the network out of nowhere. So one of the ways they do it is using browsers. They attack the browser, so they send a link or an email to one of our users, and the users clicks on it. Because the guy or whoever decided that browser were a good idea, he said that he would create something that would run on my computer, but go and find codes on the internet and run them on my computer. So this is what the browser does. So the browser goes and finds code somewhere else, codes I don't know. It can receive commands, so from the internet. It can redirect to other commands. So I'm trying to visit one page, it's redirected, the browser redirects. And I have lots of ads on, applications and updates. So it's basically, I'm open to the internet. Things are getting easier for attackers as well. Anyone knows what this is? Yeah, it's a blue box, right? In 1976, if I wanted to call myself a hacker, I would need one of these. So I could either make one, or because I'm a script kiddie, I'm a noob, I would have to buy one. And to buy one, I would have to go to a university, find the guy who made them and sold them because these were not very legal, so it was not easy to find these guys and buy one, take all this risk of going to jail and money, etc. Today, if I want to be a hacker, all I have to do is, Google it. So attacking has become much easier as well. So we said complexity, expansion, and connections, connectivity is making everything more dangerous for us. That's not all. We are starting to see that browsers, for example, I just gave the example, they are becoming part of the operating system. You are running Explorer without even noticing it on Windows. When we are going mobile, we have distributed systems, we have more and more web applications, so everything is becoming more and more difficult for us. So if we were able to write code that didn't have any bugs in it, we would be in trouble already with all this, because we're trying to connect everything to everything, etc. But we are also not able to code and design software correctly. This is Admiral Grace Hopper. She found a bug in one of her computers and she taped it in her logs. Some say that this is where the name bug comes from. Well, for us, a bug is not important. There can be a bug in a software. It wouldn't matter security-wise because, it happens. Where it starts to become a problem for us is when an attacker can take advantage of this vulnerability. He or she can exploit that vulnerability. And I'm talking about errors in coding, but coders are not the only reason we are having problems. We also have some issues designing secure software. So we cannot design it securely and we cannot code it securely. So that's why we are having problems. Errors that come from the code, sometimes they come from functions we are using. You might say that, okay, most of the compilers today, they take care of buffer overflow, but still most of the software we are using today were developed or designed, or part of them were developed or designed before all these controls, so we still have dangerous functions in them. And bad error handling is also an issue for us. Just to give an example of bad error handling. Again, from yesterday's course. This is a screen that wants me to write an ID, and it gives me back the ID that corresponds to it. So where bad error handling comes in is that if I give it a single code, it will give me an error message saying that, okay, the problem is here, and by here it will show me part of the code that is running behind it, so I will be able to attack it. This is a good example of bad error handling. A rather better way to handle errors, still not perfect, but here I have something that asks for an ID, but I can try to trick it using a number. It will not return anything. Okay, I will still try my single quote, see if I can get it to talk to me. Well, it still changes because, as you can notice, I don't have the table anymore, but it doesn't give me the line of code that is running or the error as the other one did. So this is, it can be considered better error handling. So things that we don't normally notice when we are coding, what would happen if the software has an error in it, they can be very important for the attacker. And the design, of course, we share modules with other software, we share modules with other networks. We don't use safe data transfer protocols, so why encode something when we are transferring it, right? We don't bother doing it. And we have problem also managing all that is related to user session and authentication. We need to start thinking about security the moment we have the idea of a software, so you can come up with a brilliant idea for a new mobile application. If we sell 1 million mobile application for €1, that makes €1 million, it's good business. The moment you have this idea, you should start thinking about security. That's where it starts. And also something that we forget about is security after the release. So once the software is out there, things change, because the attacker, he will not care. You might be waiting for a number or an input, anything, but the attacker, he will try, or she will try, to give you something else, so that it generates an error, so that it makes a mistake, so that it crashes. And we need to be able to understand the attacker's point of view. So if you think you have put a measure somewhere, the attacker will find a way to go around it. So what does he or she need to be able to attack or hack your software? It needs an injection vector, so somewhere where he or she can send an input, just as we have seen, a single quote or a letter or a number. He needs an activation zone. This is where this input will be handled. He needs an output and a feedback. So somewhere to send the attack code, somewhere just to send a single quote, as we have just seen. She will try to understand what different types of inputs are accepted or rejected. So just now we have seen that numbers were okay to some extent, but commas are not, or single quotes are not. And obviously it should produce an observable result. So if it didn't change anything when I put a single quote, then I would not be able to tell that there was an SQL injection flaw there. But since when I put the single quote, the table disappeared, I was able to tell that, okay, something's changing. I need somewhere to run this attack code, so it can be a database back there, it can be a DLL, anything. I need an output, of course, just to understand how it goes. And of course, I will need a feedback. For example, if it was an SQL injection, I would need the information on that table. Or if I was trying to attack an exe or an executable file, I would need a remote shell or something. Okay, let's go over quickly the steps of an attack. This is sometimes close to what is sometimes referred as to a hacking cycle, but it starts with target selection and goes all the way to exploiting. The attacker can find the targets in many different ways. You can scan the network or scan the ports or just fuzz. We'll just see an example now. And find the error that he or she could exploit and place the backdoor and delete traces. This is what we would expect when we are talking about attacking a network or attacking a web application, but when we are attacking the executable files or any piece of software, we need, or even with web application hacking, we need to reverse engineering. So we need to understand what the guy who coded it was thinking. And we have seen that he was thinking that people can write their names, it's okay, people can write a letter, it's okay, but maybe he didn't think about people putting a single quote there. So we need to understand how he was thinking and what he was thinking when he was developing the software. Okay. And we talk about security just to have the basics. We can say that any application is secure if it only does what he has to do and he does everything it has to do. So these are two criteria. If your software fulfills those two criteria, yes, we can say it's a secure software. But if I can find a way, yesterday we had seen an example with code execution. So it was supposed just to send ping packets, but we were able to download a file using it. So this was something that it did more than it should, and it should do everything that it should. As I said, secure development starts when we first have the idea, or it should start. Usually it doesn't work that way. That's why we have all these problems. But it should start the moment I have the idea or the moment I begin my development process. And at that stage, I should be able to understand all my security risks. That's how I will design a software that will cover all my risks. And even before I come to secure coding practices, not using dangerous functions or handling input or sanitizing input, all these things, I need also to choose a security architecture. How will I keep my, say we are talking about a web application, how will I keep it secure? Where will I put my controls? And then test, of course, before shipping. I'm a penetration tester, so most of the web applications I test them after they have been, coded and finished almost. Some of them after they have been deployed. So when I find a bug or an error, it's very difficult and sometimes almost impossible to fix them. But if I had discovered them at the beginning, when it was just designed, or between two sprints of the development, it would have been much easier to go to the source code and change whatever created the problem. I will not bore you with all these things, but to be able to say that yes, we are at least trying to have secure coding practices, I need to control my inputs. I need to control the user authentication. Error handling, as we have seen, for us it's just an error. It just shows that the software is not working or will not do what the user is asking for, but the attacker will see it in a different way and maybe use it to conduct an attack. Secure protocols and password management, all this I have to think about during the coding. Okay. So why do we do reverse engineering? Why are we trying to understand how a solution works or how any piece of software works? First of all, we might do it just to understand, say someone is trying to sell me a firewall, just to understand if the firewall will do everything I'm expecting for it. I might try to reverse engineer it to some extent. If I'm developing, say, for example, a piece of hardware for an iPhone, then I would maybe need to reverse engineer some part of that iPhone so that my component will be integrated and will work with that other piece. I do it to discover vulnerabilities. This is where the bad guys work. They don't care about developing hardware for iPhones, obviously. And discover undocumented functions. Everyone knows that there are tons and tons of functions that are not documented, that are used by developers or R&D department, but that will not appear in your user manual. For reverse engineering, there are a couple of things. Now we are talking about applications and application security. So when it comes to reverse engineering, maybe there are things that can help me. One of them is source code analysis. I could audit the code, the source code, and try to see if there are any functions that could be dangerous, that could lead to a compromise, things like that. And just to give you an idea, one tool I can use to do it is called RATS. I think it's raw auditing tool, something, I forgot the name, sorry. And just let me clear that, just a sec. So I'll just run it on the CLAM antivirus. Anyone is using it or heard about it? CLAM, it's, yeah. What do you think? It's a decent piece of antivirus. Are you using it? Oh, I'm sorry, great. Okay, so let's see if there are anything that could be dangerous on the code. So this is the code. I'm gonna look at clam scan, and under clam scan I have manager.c. I'll just because RATS is good with C code, so okay. Here is the output. It found some, vulnerabilities that are problems that it considers high. For example, here on several lines, it found a fixed size local buffer. So we will just see an example of a buffer overflow and where it can go. He thinks that this function will lead in the way it is used will lead to a buffer overflow. And then again, it's printf, it tells me that to make sure that the argument that is passed with this function, etc., etc. So just by looking at the source code without even trying to work on the executable or to reverse engineer the executable, I can just audit the source code and see if anything goes wrong or anything is a bit risky. I say that it's 2015 and we still cannot write a decent piece of software. The main reason is that the industry as such is not a real industry, one might say, because if, say, we go with the example of fridges, we bought a fridge, we come home, we plug it, it doesn't work. So what do? You take it back, yeah? You don't, maybe open the door, close it, see if it starts working, or because, we buy software and it crashes and we reboot it and everything goes to normal. Right? We don't take back the software. We don't say, hey, Windows, this piece of software crashed. Please take it back and give me one that doesn't crash. We cannot say this. So this is, and if you read these guarantees, software guarantees, you will see that most of the time there are none. So that's one of the problem. The manufacturer, he doesn't take any responsibility. That's the case. And we don't have anyone that checks for software. For example, if there's a plane accident, there are people that start looking into it. So why did it happen? How did it happen? What can we do so that it doesn't happen again? But when your Windows crashes, no one comes to your home and checks this. So this is one of the reasons that everything is so difficult. Just an overview of the software development cycle. Yeah, we need some requirements. So we said that we are going to develop a mobile application. We will sell 1 million of them for €1 each, and it will be our first million. So we will have some requirements there. And then we will design it. We will design how it works. We will design the user interface. We will start coding it, and then testing it, and deploying it, hopefully waiting for our €1 million. The ones in yellow are the steps in which we include vulnerabilities. So if we don't make any mistakes on these 3 steps, then we are sure that in testing and deployment, we will be almost okay. So these are the 3 most critical steps for us. I talked about fuzzing. Fuzzing is basically throwing a lot of information to the software and hoping it crashes or gives an output that is not expected so we can work on it. And there are several reasons I do it. I just fuzz it maybe to find a target. So I just download an executable file from the internet. I start fuzzing it, see if it's exploitable or not, just to play around. But for the fuzzing process, I need the executable, as I said, or anything I can fuzz. Find the input fields. So where can I send input so that I start this process? What will I send? Again, it's important. Start fuzzing. Fuzzing, it depends on what you are working against. It can take just a few seconds, or it can take days, or maybe weeks. Observe the results and see if I can find anything exploitable. Buffer overflows are rather easy to understand. That's why, as I understood them, I'm sure everyone understands them. So if I have, 8 letters and I'm trying to string copy them using the function string copy in C, I'm copying them to a buffer with a place for 5. In the normal life, I would expect it, just to write 5 and drop the other 3. Right, this is what I would expect because it has no room for it. But what happens is that it accepts the other 3 and it writes them somewhere. So, and we as an attacker, what we need to do is find which 3 letters and where he writes them. So, why do buffer overflows occur? Well, you don't have any buffer control, or you have too much buffer control. It happens. You use functions that do not that allow buffer overflow, and you don't use secure practices. So that's why we find them almost everywhere on any piece of software. So how do we exploit it? We find the buffer overflow, so we find the place where it crashes. We send the exploit, and we hope everything works. So how do we find vulnerability on any piece of software? Anyone working on this here, or finding vulnerabilities, hunting bugs, and no? Okay. So you can start working on it. It's very easy. All you have to do is use, these are free solutions, some of them open source. Vuln Server was developed specially for this situation so that you can download it. It's an executable file. It has 1 DLL, so it helps you learn these things. Immunity Debugger is a debugger we are going to see, and of course, Python, which is my favorite language. This is what Immunity Debugger looks like. So you have your assembly code, your registers, the stack, and the X. Maybe we can just go over it. I think it will be much better. So Windows is in Turkish, but I think we'll be able to understand each other. This is one server, so it's not very impressive. It just says it's waiting for client connections. It's listening on port 9999. Okay, and I'm going to attack it using Kali Linux. And okay, just to first connect it, maybe just a second. Okay, so it says, welcome to vulnerable server, enter help for help, enter help, and it lists all the functions. The one we will try to use is Tron, and it doesn't do anything, but you can just send it a bunch of A's. It just does whatever it is. So what I'm going to try to do is see if I can get this Vuln server to crash. It has seen my connection. So let's see if I can get it to crash. I could do this manually, write all the A's in the world I could. But it would not be very feasible. So I just wrote this. So it's very easy. It has a server, a remote port, and what it does, it asks me for a number, and it sends that number of A over. Okay, length of attack, say 1000. Try and complete, goodbye. It didn't crash. So let's see if I can get it to crash with 1500, nope. 2000. Okay, I don't get any reply here, and yeah, it crashed. Now, I know that there's a problem, but I'm really not sure what the problem exactly is. So to be able to understand the problem, I have to run, yes, one server, and I will also need my debugger. That's where the debugger comes in. So it will tell me what went wrong and why it went wrong. Just let me find it. Okay, so for now there's nothing on the screen because it's not attached to anything. I will just attach it to my one server process so that it will populate the screen with anything that is related to one servers. So as an attacker, I will not bore you with all the details. What is important for me is this. This is the place where the next command that will be executed is. So if I can change this, it means that the next command that this Vuln server will do is whatever I'm sending it. So this is what I'm trying to do. See if I can make it crash again. Now it's paused. I will just run it. Or maybe I could just arrange the screen a little bit here. Oops. Just a second. Let me arrange the screen so that we have a better pictures. So what is good with the demos is that you can see what really is going on. What is bad is that most of the time they fail. So sorry about that. Anyway. Okay, still ugly, but you know, we said that this is what was important. So I just run it. It's running, and now what I will do on my Kali machine is try to make it crash again. So we know that at 2000 it crashed. So let's see what really happened. Well, it crashed, yes. Here I can see that, well, in fact, that's important for us. It says that it has an access violation when it tried to write to 41, 41, 41, and 41. So going back to the boring presentation, this was the code that I sent, and it crashed, saying that it had a problem trying to write to this address. And for those who know, 41 is hex for A. Yeah, that's what. Yeah, okay, thank you. So that the A's I sent him, some of them, the Vuln server, the software, thought that there were a place in the memory to write something, and it crashed trying to write there. It's interesting, but it's not exploitable. Why? It might be exploitable, of course, but if it took one of the A's or some of the A's as an instruction and as the next command to be executed, that would have been much more interesting for us. And I'll just spare you the agony of the demo once more. If I send 3000 A's, then yes. Now I have a crash saying that it failed trying to execute those A's. So, okay, I know that somewhere between 2000 and 3000 there are a bunch of A's that the application thinks are commands to be executed. So if I can just find the place where this would happen, it would be easy for me to send them a command. So how do I do that? I create a piece of text that doesn't repeat itself. So every 4 bytes are unique, so that I know where it failed. I just put it in my, it's the same basically as the fuzzer, but instead of sending lots of A's or as many A's as I want, it first sends 1000 A's and then this unique characters. Yes, it crashes, and we see that it crashed trying to execute this. Okay, you've read Gulliver, yeah? He's popular. So, you know the king that wanted his people to break eggs in a certain way? Big Indian, little Indian? Okay, because Intel processors are called little Indians, this, in fact, is this. That's the way they write it in the memory. So they write it starting from the end. And here are our magic. This is the magic place. So whatever I put here, it will be accepted as a command to be executed. And the location is at 1006 bytes from the beginning. So what I need to do now is just send our 1000 A's, send, and then 1006 other bytes. So at 2006 bytes, whatever I put there will be executed. Try if it works. I just put my name here, and as you can see, yes, that's the place I've checked it. The problem with developing the exploit is that there are some characters I will not be able to use because the software or whatever is that interprets the software will think these are commands for him and will do something. So just to be able to understand if there are any characters in that range, that starting from 0 going to 256, which are all the characters we can do with a computer. Oops. sorry about that. I will just send, my initial 2006 characters. Then I will send all the characters I can, and then I will, finish the rest, because I need, in fact, 3,000 characters to make this exploit work. So if it's less than 3,000, it will not be the same crash. My exploitable piece of memory will not be in the same location, etc., etc. So I need exactly 3,000. What I tell it is, okay, send 2006, then my what I want to be executed, and then all the characters you can, and for the rest, just put a bunch of Fs, just to add it to 3,000. And when I run it, I see that the Fs don't arrive in the, are not executed, are not accepted. So one of the characters amongst this was a bad character. In fact, was something that made the exploit fail. It didn't work. So this is a bit tricky. It might take some time, or sometimes you might get lucky. So now instead of starting at 0, I start at 1. I say, okay, omit the first character, don't use it, see if the rest is good. I run it, yeah, now I see that the Fs and all the other characters reach the memory, so it's okay. The bad character, in fact, was the null byte, the first one. So now that I know that something, what I can change, and where I can find this thing I can change, I need a command to put there. Writing my name is cool, but it will not pay the bills. So as a hacker, I need something that will help me pay the bills, a virus or a backdoor, something like that. And for this one, I can use several components. I can find the command inside the executable file, or I can use one of the DLLs that comes with the software. Here, it's an add-on for Unity Debugger called Mona, and it will list everything that this executable is using. These are things that I don't notice, so even the Windows kernel should be listed there. And it also shows DLL. Why would that be important for me? Because in order to be able to make my exploit run on every machine, I need, we know the exact place of that address. It's 2006 bytes. And now I need a command to put there. And I need to make sure that the place of that command doesn't change when the machine changes. So how do they do it? Normally they use, I think it was address space location randomization, something like that, so that every time I start the DLL or the executable, the place changes. So this is, in fact, a security function. I see that two components that help me run this application don't use it, were not allowed. So the ASLR is false. One of them is the executable itself, and the other one is a DLL it's using. Okay. I cannot use this one because it starts with 00, and I said that, and I've just seen that null byte was not working with my with this vulnerability, so I cannot use it. The only one I can use is this one. Okay, so now I need to find a jump. So because what I will do is, as I know where I have to put the next command to be executed, I will put a jump there, and I will make it jump to my own exploit so that I can exploit the application. Inside this DLL, I find like 9 or 10 jump functions. I will just use one. My exploit, I will use MSF Venom, which is, which used to be MSF payload and MSF encode. Now they have put it together. Just it will open me or give me a reverse shell. This is just maybe an important point. I ask it not to use the null byte because it's a bad character. So if I put it in the exploit, it will not work. So I just ask it politely not to use it. But the rest is just open me a reverse shell. This is my local host and on this port. So it generates the payload. Just let's maybe go over it. again, let's see if I fail in another application. So I'll just close everything. I don't need the debugger anymore. So this is Von server running. I mean, Kelly. I will just need a listener because I am asking it to open a reverse shell. I'll just start listening on a port. And just let me show you the exploit. Again, it's the same piece of code. It will send 2006 A's, then the location of that jump function I found, because I wanted to go there. And instead of putting all these F's at the end, I will just put the payload I just generated. So really simple. I think need to change this so that works. Exploit. Oops. Okay. I've sent it the attack. The length is 3000 because that's exactly what we needed. And see what happens with my listener. It was listening and, well, it got what you might call a shell. So now I'm, inside the Windows machine. So that's basically how it's done. Just to go over the process once more with the slides maybe, to make sure everything is okay because we had to go back and forth. This was my fuzzer. Just I tried to make the program crash or make sure the program gave me an error. I run it a few times and I've seen that it first crashed at 2000, but it was not very usable because whatever input I was sending it thought that it was something to write on, so it was not very exploitable. At 3000 it crashed, and this time it was okay. My command was accepted as such, as a command. I just needed a string of characters that were not repeating so that I could develop and locate my exploit. I did this, sent it over, found the location, and because it was big endian and little endian, all these good things, this was my location so that I knew that whatever I sent after this first 2006 bytes would be accepted as a command. Just to make sure, double check, yes, it is accepted as a command. There are some bad characters that we should avoid because it might terminate the string or the line. So just to test them, I'm sending all the characters there are in the world. Test, yes, one of them makes that this is not working, something goes wrong. Now I send the remaining, I start one by one eliminating the characters until I find the good one. I'm lucky in this case it's null byte. Yes, so it works, it's okay. I'm using the Mona add-on for the Unity debugger just to find the location or the DLL or the other executable I can use to build an exploit. It gives me two possibilities. The first one is the executable itself and the other one is the DLL it is running. Because of the address of the executable, I cannot use it. It has a null byte in the address, so it will create a whole bunch of problems. I decide to use the DLL. I need a jump function, again, using Mona. I find a jump function inside the DLL. I use any of them. I took help from MSF Venom to build a payload. So the payload is basically for Windows. It's a reverse shell on TCP. My local host address, my local port address, so this is the ports it will connect back to. I asked him not to use the null byte and some encoding. And for the output format, I asked it to output in Python. So this is what it generated. I start my listener on my attacking machine. And once I send the payload, everything's back to normal. You will notice that in the last case, the software didn't crash on the machine. So here I am connected to it, but if, yeah, Von server is still working, so nothing crashed. Yeah. So this is more or less the process and all the idea behind it. If you have any questions, I can try to answer them. Okay. Yes.
So you were telling about deleting traces. The server or whatever the Windows machine is, won't he be able to see our IP address or the IP address he's sending?
Yes, in this case it will. You know, it has seen our, as you can see, it has seen our connection. It has received the connection. So it will be, they will be able to see who connected. This is an early stage. Usually, this is not how, where I will stop. You know, if this was a real company and it was a real attack, once I got in this position, I would use the Windows machine to get a better backdoor or a remote access Trojan, because, you know, someone just can close this application, or just they can just shut down their computers and go home. So it's not very usable in real life. So I need to move laterally or, you know, somewhere else. I will leave a trace here, obviously, but I can then go back and delete it. But in the first contact, yes, we will leave this trace. Okay. Thank you very much then.